is essentially putting operations with rational expressions first example, we are adding these two rational functions together. Of course, whatever we add, we must have a common denominator. You can see here that we do not have a common denominator. So we need to get a common denominator. Well, the fraction on the left has the denominator x minus 2 times x plus 1. The fraction on the right has a denominator x plus 1 times x minus 1. So in order to get a common denominator, we need the fraction on the left to have an x minus 1 term, and we need the fraction on the right to have an x minus 2 term. So we need to multiply this by x minus 1 over x minus 1, and we need to multiply this by x minus 2 over x minus 2. So let's start on the left. In order to multiply, our denominators are just going to be there. So we're going to have x minus 1 times x minus 2 times x plus 1. But in the numerators, we need to FOIL together x minus 1 times x minus 1. So we first would be x times x, which is x squared. And the outside terms would give me negative x. The inside terms would give me negative x. And the last terms would give me positive 1. I can even rewrite this as negative 2x, because of course they are like terms, so we'll put negative 2x there. We'll bring down our plus sign right here. So we have plus. Now we're going to do the same thing on the right. Now we'll just write down our denominator, x plus 1 times x minus 1 times x minus 2. But we have to multiply the numerators. So in this case, we have the x times the x minus 2. So we have to distribute the x. X times x is x squared, and x times negative 2 is negative 2x. We have our common denominators, so we can add all the terms in the numerator that are like terms. So we have an x squared here and an x squared here. That will combine to give us 2x squared. We have an x term here and an x term here. So those would combine to give us negative 4x. And then we have the constant plus 1. And there's no constant in the other to combine that with, so it'll just stay plus 1. And we keep our common denominator, x minus 1 times x minus 2 times x plus 1. Alright, second example. Same thing. We are now subtracting these two rational functions, or these two fractions. If you just think of them as fractions, it's the same process as adding or subtracting fractions. We need a common denominator. Well, these two fractions don't have any terms in the denominator in common. Right? We have x minus 3 and x plus 4. Here we have x plus 1. So we are actually going to need an x plus 1 over here, and we're going to need an x minus 3 and an x plus 4 over here. So we multiply the left by x plus 1 over x plus 1, and we multiply the right by x minus 3 times x plus 4 over x minus 3 times x plus 4. So we write down our common denominator. And we start multiplying our numerators together. So over here on the left, we have to FOIL these together. So x times x is x squared. X times 2 is 2x. 1 times x is 1x, and 1 times 2 is 2. 2x plus x is 3x. So let's actually just replace this with 3x as our middle term. Now, let's do the other part. Now, I'm going to call this a negative 5. Let me think here. Actually, let's do a side note first. First, we're going to FOIL these together. So let's do that first. X times x is x squared. Outside terms will give me positive 4x. Inside terms will give me negative 3x. Last terms will give me negative 12. Combine my x terms and get x squared plus x minus 12. Now we need to distribute what I'm going to call a negative 5 to every term in this new quadratic. So I'm going to get negative 5x squared minus 5x plus 60. Now we can combine all the like terms that are in the numerator. We have x squared minus 5x squared, which would be negative 4x squared. We have 3x minus 5x, which would be negative 2x. We have 2 plus 60, which is 62. All over our common denominator. Right there. Alright, here's an example of a multiplication problem. So we know that when we multiply fractions, we multiply the numerators together, we multiply the denominators together. So that's what we're going to do. We're going to have x plus 2 times x plus 1 times x minus 3. All over x minus 3 times x minus 1 times x squared minus 4. Now, before you start multiplying, look to cancel out things in the numerator and the denominator. Like, for example, right off the bat, x minus 3 and x minus 3 cancel each other out. That's a lot less multiplication that you're going to have to do now. And there's even more, because x squared minus 4 is a difference of 2 squares, right? And it factors into x plus 2, x minus 2. So let's do this. Let's rewrite this as x plus 2 over x plus 1 over x minus 1 times x plus 2, x minus 2. And you can see that the x plus 2's are going to cancel out. So now we have x plus 1 over x minus 1 times x minus 2. And we can stop right there. Alright, our final example is a division problem with rational functions. And you remember that when we divide fractions, we multiply by the reciprocal of the denominator. So that's exactly what we're going to do here. We're going to have our fraction in the numerator, x squared minus 1 over x squared plus 5x plus 6. And we're now going to multiply that by the reciprocal of the denominator. So the x plus 3 comes up on top, and the x squared minus 3x plus 2 ends up on the bottom. Now we have a multiplication problem. Now there are a lot of quadratics in this, and we need to factor those quadratics. So x squared minus 1 factors into x plus 1, x minus 1. X squared plus 5x plus 6 factors into x plus 2 times x plus 3. Times x plus 3, we can't factor that anymore. X squared minus 3x plus 2. Let's see, x minus 2 times x minus 1. So we factored all those, and the nice thing is there's going to be some canceling out here. So we have x plus 3 and x plus 3. We have x minus 1 and x minus 1. And that's it. So now, our problem becomes x plus 1 over x plus 2 times x minus 2. So in this case, we actually didn't even end up having to do any multiplication.